Hi guys, welcome back to the channel. So today we are going to be solving today's lead code question, which is subarrays with k different integers. So we are given an array of nums and then integer k, and then we need to return the number of good subarrays in this particular nums. A good subarray means we need to have number of different integers in this particular array should be exactly k, and then suppose if we take this particular example and then k equal to 2, that means the different integers present in this particular array should be always 2. That means we can pick 1 2, we can pick 1 to 1, we can pick 1 to 1 2, and then we can pick 2 1 2, and then we can pick 1 2, and then we can pick 2 3. So these are the different subarrays which we can pick, so that the number of different integers present in this particular array is exactly 2. So to solve this particular example, we are going to take, if we come to the brute force approach, we'll take the starting point as I, and then we are also going to consider ending point which is j, and then we are going to consider the number of different integers from I to j, and then we are going to store in set. And then suppose if the set dot size is equal to k, then we are going to consider this particular example, this particular array, and then we are going to increment the answer, and then we are going to return the answer. So for this, the time complexity is going to be big of n cube, and then for insertion and deletion, for inserting the elements into the set, it is going to be log n. So this is too much time complexity, so we need to optimize this particular solution. Suppose instead of doing this particular thing, we can use the sliding window. Suppose let us take that we are given, at most we can take, we are given that the number of different integers present in this array should be exactly k. That means suppose if I have this particular thing as like this, now there will be a line where k equal to some 3 or anything, 3 or 4, depending upon our solution. Now I have k greater than 3. So this is going to be, so these are the total number of subarrays which we can build from the array, and then this is k is less than 3. So this is what our region for this, and then this is the region, and then this is the region for this. Now I want this particular line, only this particular line, and then I don't want this, and then I don't want this. There are two different approaches that we can solve. So the first approach is take whole array, take this whole number of subarrays, and then we can remove this particular k greater than 3, and then we can also remove this k less than 3, and then we'll get this particular k equal to 3. And then one more approach is, suppose if I take this particular example where I have k is less than or equal to 3, so I'm going to consider the maximum it can have is 3. So out of this, I'm going to consider one more case where k equal to 2. So this is going to be my k equal to 2, and then now I am going to consider where the at most it can have is 3. This is going to be at most. That means it can have maximum 3, and then it can have less than 3. So that is going to be my constraint. And then for this, the maximum it can have is 2, and then it can be less than 2. So out of this particular region where we have like this, we are going to remove this particular thing, that is k is less than or equal to 2. So this is what we are going to remove, and then we'll get this k equal to 3 as our answer. So and then one more approach for this is going to be considering the next approach where we are going to have k is greater than or equal to 3. Now for this particular case, we are going to have the maximum, the minimum as 3, and then it can have more than 3. So there should be at least 3, and then it can have more than that. So we are going to consider k equal to 4, and then out of all k equal to 3 and then greater than 3, we are going to remove this particular region, and then we are going to get this particular answer. So this is going to be our approach. Like, we'll be taking one function, and then we'll be using based upon the other function. And then for this, if I take this particular example where we have 1 2 3 and then 2 3, then I'm going to consider the left and then right pointer. So let us go through the code so that we can understand, and then we can do the dry run. So there are going to be two approaches. The first approach is, we are going to consider the total number of subarrays which we can build from this array, and then there are going to be subarrays which with the distinct integers less than k, and then there is subarrays which greater than k. So we are going to remove the less than k and then greater than k, then we are going to get the equal to k. So this particular less than k, we are going to take the map, and then we are going to consider the left and then right pointer, and then we are going to consider answer. Suppose, let's say, we are moving this particular sliding window where we have left and then right. Now it should be, we are moving the right to like this, and then whenever the map dot size, suppose if I increase this particular nums of right plus plus, and then the map dot size is greater than or equal to k, that means the number of different integers present in this particular subarray is greater than or equal to k. That means we need to reduce this particular sliding window so that we will get the less number of different integers present in this particular sliding window. That's why we are going to move this particular left, and then we are going to decrement the frequency of that particular element present in this particular sliding window. And then whenever the map dot nums of left equal to 0, then we are going to remove that from the map, and then we are going to increment the left. And then whenever we say we have a sliding window where the map dot size is less than k, that means we can consider from starting from left to right as our answer, or left plus 1 to right, and then left plus 2 to right, till right to right. So that is going to be our answer for this particular sub sliding window. And then we are going to increment the right, and then we are going to return the answer. So this is going to be for subarrays less than k. And then if we consider the subarrays greater than k, then we are going to write one more function where we have the same map, and then left and then right. For this, we are going to consider a different approach. Like, suppose here we have left, and then we have right. Now we'll take right till the map dot size is always less than or equal to k. That means, suppose if left is here and then right is here, and then map dot size is less than or equal to k, now we need to increase more than k. That means we are going to increment the right, and then we are going to add the elements into the map or the sliding window, so that we will have the map dot size greater than k. And then whenever we have mp dot size greater than k, then we are going to consider nums of, suppose this is nums left and then right. Now we are going to consider from right till end of the array. So these are the different subarrays we can build with subarrays greater than k. And then now, suppose, let's say, after completion, after traversing till here, now we need to make a transition from left to left plus 1. So this is going to be one more sliding window. And then for this, again we'll start right, and then whenever if it is less than, map dot size is less than or equal to k, then we are going to increment the right, and then we are going to add the elements based upon that. And then at last we are going to return this particular subarray greater than k. So this is going to be one approach. And then if we come to the another approach where we have subarrays with k distinct, we are going to consider utmost function where we have nums and then k. So this is going to be maximum, the number of digits present in this particular array maximum can be k, and then it can be less than k as well. So, and then for this particular thing we are going to consider k, and then we are going to consider k minus 1. That means it is going to start from 1 and then 2 and then 3 till k. And then now 1 2 3 3, this is going to be k minus 1. Now for this it is going to be k minus 1. So this is going to be our answer, and then now at most k is going to have k and then 1 and then 2 3 4 till k minus 1 and then k. At most k minus 1 is going to have the different integers where we have 1 2 3 and then k minus 1. So we are going to remove this particular till k minus 1, so that we'll get only different integers equal to k. So that is what we are going to consider. Now we are going to take the map, and then we are going to consider I and then j, and then answer equal to 0. Now we are going to increment the nums of j plus plus, and then let's say the map dot size is greater than k. Suppose we have a sliding window where it starts from I and then ends at j. Now the map dot size is greater than k. That means it exceeded the k. We should not have more than k. We should decrement such that it will be number of different integers present in this particular sliding window is always less than or equal to k. That means we are going to increment I, and then we are going to reduce the number of reduce the elements which are present from the left end of the sliding window. And then let's say if the I is less than j and then maps dot size is greater than k, then we are going to decrement nums of I, and then if the frequency becomes 0, then we are going to erase it from the map, and then we are going to increment the I, and then we are going to consider the answer equal to j minus I plus 1, and then we are going to increment the j, and then we are going to return the answer. So for this we are going to have the time complexity of big O of n, and then the space complexity is going to be big of n. Why? Because we are considering extra space for the map. Yeah, that's all for this video. Thanks for watching the video.